My talk is centered around React Server Components, and the agenda of this talk is to explain React Server Components from the perspective of static sites. We have built static sites in the past, but React Server Components has been introduced, and we can't really relate where React Server Components fit in the static sites model. So by the end of this talk, hopefully I'll break some myths, misconceptions about what React Server Components are, and eventually together grow a better understanding of what this new technology is. My name is Akash Hamirwasia. I work as a software engineer at Razorpay. I love building products on the web. My latest product is slanted.app. It's a video creation tool to create stunning looking product videos from simple screen recordings. You can follow me on Twitter, GitHub, and I also have a website. So how many of you remember static sites? Okay, I can see a lot of hands, that's good. So a lot of popular sites use static sites. Most of the documentation sites for React, for Vue, they are built on static sites. Some unpopular sites, like my personal website, is also built on static sites. If you don't really recall what static sites are, well, you start with source code, something like this, a framework like Gatsby or Next.js. You create your components for each of the pages. You use some fancy styling library like Tailwind. You use state-of-the-art programming language like TypeScript. And you build your source code to produce HTML, CSS, and JavaScript that the browser understands. And then you upload it on a file server. Now what happens is, when a client comes to your file server and requests for your website, your file server simply returns all the files that it has about your website, the HTML, the CSS, the JavaScript. Let's say another client comes in. That client also receives the same set of files. So in a way, the client 1 and the client 2 is seeing the same website because the files are the same for both of them. Now let's say a different kind of client comes in, which is a web crawler. Well, it can't really understand JavaScript, right? So it will only request the HTML and CSS file to get a sense of what the content of your site is to perform its search rankings. Now what's interesting in this is that this file server is not really a smart server. You can think of it as like a disk whose job is to simply return the files it was requested for. It does not know how to generate those HTML, CSS, or JavaScript files. It just knows that I have these files. If someone asks for it, I'll return it to them. Now this is fine, but most of our sites usually have some dynamic content as well, right? Take my personal site, for example. I have a blog section where I write some technical blogs, and most of these blogs come from a third-party CMS service that I'm using. How do I fetch this dynamic data from that third-party source? So that's the question. How do we show dynamic data on a static site UI? Well, we can simply use APIs and fetch, right? That's what we have been doing since the dawn of fetch. So this is what the code looks like. I'm sure we have seen this multiple times, and we have written this thousands of times, I guess. So we insert a simple use effect, call the API, set the state, and our postcard show as we expect it to. Now let's try to understand this from a waterfall model. So we have server and client. The server returns the HTML and the JavaScript to the client. And the client realizes that, OK, there's a use effect hook which calls an API. So it makes the fetch request to the server, fetches the blog post, and once the blog post is received, it again runs the JavaScript and renders all your blog posts on the UI. Now the problem with this setup is that it provides a poor initial performance and poor user experience. The user sees a spinning loading page, and after some time, the posts come in. Imagine what if you open a documentation site and the docs actually come in after like 10 seconds after you wait. Really bad experience, right? The other downside is that the search engines cannot really crawl the content. Because the main content of our page is actually those posts that are shown, the search engine does not get those juicy content to actually perform its ranking. So it only sees navigation, footer, that's it. Not really a lot of data to get a sense of what your site is. So this is not really a good approach. Can we do something better? Can we fetch data before the UI is sent to the client? Notice the word before UI is sent. So let's try to understand this better. UI rendering in your application is handled by React, right? We write React code, we break our UI into components, and React's job is to take those components, the state, everything, to render that UI. Now, what I'm saying is the data fetching should happen before the UI is sent. That means before UI rendering. So how do we do data fetching when the UI rendering happens after data fetching? We have to rely on some other tool. What can we use for it? Oh, we can use frameworks, right? That's what frameworks provide. At least one of the features of frameworks is to perform data fetching. Frameworks like Next.js, Gatsby, even Remix have primitives to allow you to fetch data before the UI is sent to the client. For these respective frameworks, this is how the code looks like. For Next.js, you use a function called getStaticProps. And for Gatsby, you simply expose a special variable called query, which includes the GraphQL query of the data that your component needs. So the blog post component that I had earlier, it can simply be updated to something like this. I can add a getStaticProps function, which fetches the data, parses it to JSON, and simply returns it as a prop that my page can accept and render the post component. Now let's try to see what happens in the waterfall. So during build, the JavaScript is parsed, the data is fetched, and the output artifact is simply HTML and JavaScript files that is pushed on the file server. Now when the client requests for the file, it gets the HTML, JavaScript, and all the static files that are there. And notice how the UI is partially ready as soon as the HTML is received. The client does not really have to wait for the JavaScript to load. The JavaScript loads for hydrating and making your UI interactive. So in a way, the user is getting value just by loading the HTML of your page. So this is great, right? This is exactly what we need. Why am I giving this talk? The problem is these two primitives, and even the primitive exposed by Remix, those are at route level only. So you need to create special pages component, and only in those components you can expose these functions where the data fetching can happen. This sort of setup works fine for the blog posts page that I have, because again, it's a page, I can perform data fetching over there itself. Let's try to take a bit more of a complex example. Say I have this simple component which shows all the GitHub sponsors I have, and I use this component throughout my website. I show it on my projects page, I show it on the blog post as well. So how can I use this component throughout my website and ensure that the data is still passed to it from GitHub, which is again a dynamic data? This is what the component looks like. Really simple, takes a single prop, which is sponsors, and it renders that in the JSX markup. Now let's say I update the projects page to include this component, and notice how I have to put my data fetching logic inside the getStaticProps function. And this code, the data fetching code that I've written, is already mixed with the other data fetching logic that I might have for this page. So for the projects page, I might be reading a YAML file or calling another GitHub API to get all the projects, and then I have to fetch for the sponsors and ensure everything is returned from that single function so that my page gets all the data it needs. Now let's say I want to render the same component in the blog post page. So this is the blog post page. I can move the JSX itself inside the blog post, but that's not it. I also have to remember to copy the fetch function from the getStaticProps method and paste it in my blog post page. So notice how I need to remember two things. One is the JSX component itself. I need to copy and paste that. And then I have to remember, OK, this needs the data. So I need to get that data also from getStaticProps. So I need to copy paste that code as well. And everything is cluttered in that single getStaticProps. You have things happening. You might be calling ChatGPT or doing fancy stuff. Everything is cluttered in that one single function that is exposed. Can we do better? How many of you know Gatsby? People are still using Gatsby? No, everyone's hands went down. OK, so the thing is, Gatsby actually had a really smart solution for this. It introduced this smart hook called useStaticQuery. And what this hook allowed you to do was perform component-level static data fetching. So let's say this is the GitHub sponsor component that I have. Instead of expecting the consumer to pass in that sponsor's data, the component itself can use this useStaticQuery hook and write the GraphQL query that it wants. So in this case, I'll be fetching all the GitHub sponsors data within the component itself. I don't expect the the consumer to pass it. This useStaticQuery will ensure that when your site builds or when the component is rendered, the data will be there for your component to actually render. And notice how the usage of this component becomes in those pages. The projects page, simple JSX. Even in the blog post page, simple JSX. One single component, I can copy, paste, and move around wherever I want. I don't have to think about the data it needs. This looks perfect, right? This is what we need. Well, let's try to, again, take a step back and see what exactly use static query offers and what are the limitations. Well, we just saw that it performs component-level data fetching, and it allows you to co-locate the data fetching logic and the UI in a single component. So your data and the UI stays together, and whenever your component is rendered at some other place, the consumer doesn't have to worry about passing data or doing any of that stuff. So it has a couple of limitations as well. One is that it cannot accept variables. Let's say the GitHub sponsors component I wrote, instead of it fetching sponsors only for me, it also took a username prop and actually fetched the sponsors for that particular user inside that component. I can't really do that because username is a prop, right? And if I pass that in my query, the query is no longer static. It is dynamic because it depends on that username prop. So this is a very quirky limitation. But there's another quirkier limitation, which is there can be only one occurrence of the hook in a file. If the rules of hooks were not enough, this makes it even worse. So you can have one use static query hook in one file, and if you want to use it multiple times, split the file and split the hook into multiple files and then compose everything together. Now, the thing is, if you take a look at these limitations, it's because of the fact that Gatsby performed data fetching by static analysis of your code itself. So it went through your code, it found the use static query hook in all the files, and it performed the data fetching based on that. It did not really have the context of the components that are there, which component gets rendered when, what are the props that are passed. Can we do any better now? The static site community has been building for this for years. Use static query was the best solution that was there for the time. But we can't really go ahead, right? Frameworks don't have the context of what your components are, what the props are. What if React itself handled data fetching before rendering the UI? After all, React knows what the components are, what are the props, which component shows when, etc. So if it handles data fetching, it should solve our problem, right? Can we use React Server components? You might be thinking, yeah, that's what the talk is about, right? But wait. If it's React Server components, how can I use it in a static site? I'll need server to run the React Server component. After all, it's in the name, right? Do static sites not have a server? Think again. When you're building your static site, there is a server running, right? How is it able to build your static site? So I was going down this rabbit hole, and it made me wonder, what exactly is a server in the first place? In the context of React Server components, it's actually just a computer that is not the client. To understand this better, let's try to take a look at the waterfall again. So this is the static site waterfall. We build the site, we push the HTML, JavaScript to the server, and the client simply requests those files. Now let's modify this for an on-demand server-rendered UI and see how things change. So this is the waterfall for static site. And this is how it looks like for server-rendered site. If you noticed, the build and the server just collapsed into one, which is simply the server now. The client sends the request. The server's job is not just to serve the files, but also to generate those files by actually fetch the data, rendering your UI, and streaming the output to the client. So what is the takeaway from this? Static site is simply a frozen snapshot of a server-rendered client, server-rendered site. If React Server components can be used in a server-rendered site, they can also be used in a static site. Because again, as I mentioned, static site is a frozen snapshot of your server-rendered site. If your client is sending requests and the server is generating outputs for every single request, if you take that one output and put it in a file server, that becomes a static site. So with React Server components, this GitHub sponsors component that I had, it looks something like this. So simple fetch call, the component has become async. That's something important to note. And I can write my asynchronous logic here itself, and the data that the component needs is again encapsulated in the component code. Nice. I can also pass a prop, which is username in this case. And because this is in React land, I can call the fetch GitHub sponsors function with that prop. So I don't have the limitation of a static query, one hook per file, all that fancy stuff. I can just write asynchronous code as much as I want. And this is how the usage looks like. I can have multiple occurrences of the same component in a file. I can use it like any other component. I can pass different username. The first instance is my username. The second one is Anthony Fu, a really awesome creator in the open source community. This looks fine on paper. I'm sure you will be thinking, that guy is lying. I don't think so. He's saying the truth. So React Server Components is server rendered side. Show me the output. Well, I do have the output. Can you make sense of this? This is the minified output after you build your site with the GitHub sponsors component that I showed. If you notice, there are two parts in this output which translates to the component that I defined. The first section is my GitHub sponsors card. The second one is Anthony Fu's GitHub card. It has the data from the GitHub API. It's showing the images of my sponsors. It's showing the number of sponsors I have. React has performed data fetching and has frozen the state of your UI in this single output file. What's interesting is that this entire process or this entire system is not really just limited to data fetching. Once you start using React Server Components, you can do any sort of build time processing that we don't want the client to do. Now, this is really interesting, right? Because static sites, when you were building, if you wanted to configure the build time itself, you had to dive into framework config files. Things like Gatsby config.js, modify its GraphQL source, or in Next.js, fiddle around with that get static props, drill down the props, all that stuff. But because we are using React Server Components, we can do any sort of build time processing inside React land. An example of this is code highlighting with Shiki. So in most of the personal sites or blogs, we have code blogs that are shown. And Shiki is one of the popular and accurate libraries to get high-quality syntax highlighting with text-mate grammar, which is supported by VS Code. You can also use your favorite VS Code themes as well. But the downside is this library is sort of heavy to use. If you're shipping this to the client just to render those code blocks, that's actually a huge waste of resources. Even Shiki recommends that you use this library as a build time tool. With React Server Components, I can write a code block server component. I can get the Shiki highlighter over here. I can create the syntax highlighted HTML and pass it down to my markup over here. React Server Components will ensure that only the things that are rendered on the UI is actually a part of your bundle. You won't notice Shiki itself in the bundle. You won't notice any other data that is not part of your actual JSX that is shown. This is how the output looks like. Really fancy colors, chef's kiss, right? Finally, let's look at the advantages of React Server Components in static sites. One that we saw is component-level data fetching. This is why we started the discussion in the first place. Second is co-location of data fetching and UI in a single component. The component is self-aware that it needs this data. It needs these operations. You can do everything in the component and use that component anywhere you want. You can also have dynamic queries. When we were using useStaticQuery, you had to use the useStaticQuery hook, which has to be static query, all that fancy limitations. But with React Server Components, it just works. You can use any props, any variables, any operation to perform your queries. It's not limited to data fetching alone. You can do any build time processing. If you're calling ChatGPT, you don't want to do that on the client. You want to do it while building. You can do that inside the server component. Now, this is a really interesting advantage. Just go through this, the last one. So theoretically, if your entire static site is built only with React Server Components, you wouldn't require any client-side JS at all. All your interactivity is in client components, and that is where JavaScript is needed. But since you're using only server components, you don't need any client-side JS and no hydration at all. I say this theoretically because most frameworks won't actually do this. They will still bundle some JavaScript to make the user experience better. The last advantage is this whole system is portable to any other React framework that supports React Server Components. As React devs, we like switching frameworks every other day. So it's important that we make minimal changes throughout our transition. And if your site uses React Server Components and you move that source to another framework, you don't have to worry about data fetching and moving that logic. React Server Components works the same in every other framework. Now you might be wondering, really good stuff, right? How can I use React Server Components for my static site? Well, I'm glad to announce that on this stage, I'm announcing my own first JavaScript. Nah, it's just Next.js. Just use Next.js. So it's interesting how you can opt into static site rendering really easily with Next.js. You just have to change one line in the next config. Output, export. That's it. Don't ask me what it does. It does what I expect it to do. So it will actually just freeze everything into static files, and you can just host it on any server. Even Next.js recommends that you start as a static site and opt into server-side features as and when you need them. I'm not just saying this, it's actually in the docs, you can read it. So start as a static site if you need features like middlewares, things that are on the server, headers, cookie function, all those things, once you use them, then you can become a server-rendered application. Hopefully, this makes sense to you by now. Finally, I would like to leave 2 references. If you're more interested to understand React Server Components, these are amazing 2 resources that I've found. The first one is a blog article by Josh, Making Sense of React Server Components. The second one is a talk by the legend himself, Dan, called React for Two Computers. That brings me to the end of this talk. Thank you for listening. You can connect with me on my Twitter and check out my website.